So we're on page 543 of the Math 20 Absolute Value Workbook, looking at solving quadratic inequalities in one variable. Today we're looking at sign analysis, and that is through either using test intervals or by using a sign chart. And last lesson we looked at graphing, which is, I think, very important when it comes to understanding what your solution actually means. It's also a great way to check your work. The algebraic method that we also went through last class was through using case analysis. So let's take a look then. First, using test intervals. So test intervals, for a lot of people, this actually makes the most sense to them because it's really about picking possible values for your x, for your variable, and then figuring out if it is true or not true. So it makes sense to a lot of people. The disadvantage perhaps in some cases is that it just takes a little bit more time. Okay, so let's take a look then. Part 1, it says the graph of a quadratic function with the equation y equals x squared plus 2x minus 8 is shown below. The zeros of the function, -4 and 2, those were found by factoring. So we had factored that into y equals x plus 4 and x minus 2, and of course our zeros are when y equals 0, and so then x must equal -4 or +2. And so you can see this quadratic, because it has two x-intercepts, it's dividing our x-axis into essentially 3 intervals or 3 sections. And in each interval, the function, meaning the graph, is either going to be totally positive, so above the x-axis if you're looking at it visually, or negative, meaning that the function, the graph, is below the x-axis. So this first part is obviously not using test intervals, it's just actually doing it visually by graphing. So for the interval x less than -4, so all of these x values, and we can see our graph is here, the function is above the x-axis, so the function is positive. The interval between -4 and +2, so all of these x values, when x is -3 and -2 and -1, and x is 0 and +1. So it's hard to think about the x values because oftentimes we're seeing things in 2 dimension. We're seeing the y values. Don't worry about the y values other than the fact that they are negative, they are below 0, they're below the x-axis, and therefore in that middle interval the function is negative. On the interval x greater than 2, the function is, the graph is above the x-axis, and therefore we know that for any value, if we were to substitute in x equals 3, we're getting a positive y value. Substitute in x equals 4, yeah, you're getting a positive y value. So we don't actually really care what those values, specific values are, other than the fact that they are above 0 or below 0, positive or negative. So what we know then is that the signs of these, so based on that interval, this less than 0 should be positive, this should be negative, and this should be positive again. So before I actually write that in, I think it's good just to actually say, hey, well, test intervals. So just as I was talking about, so pick a value for x less than -4. So if we say have x equal to -5, what does that look like? Well, then that's -5 squared plus 2 times -5 minus 8. Oops. Okay, and so -5 squared is then 25 minus 10 minus 8, and that gives us then +7. And so we can see that the sign, the value of our function, is going to be positive. If we then pick a value of x that is greater than -4 and less than 2, obviously the easiest value to pick is going to be x equals 0. So then we would have 0 squared plus 2 times 0 minus 8, and that is, of course, -8. And that is obviously then negative. If I then pick a value greater than 2, so I could pick x equals 3 perhaps, so then we've got 3 squared plus 2 times 3 minus 8, or 9 plus 6 minus 8, and conveniently that also gives us 7, and which is of course a positive value. So that is a demonstration of what is using test intervals. So if we want the solution to the inequality where this is greater than 0, well, meaning we want positive values. So that happens when we chose values that were less than -4, and it also happened when we chose a value that was greater than 2. The solution to the inequality when the function was less than 0, when it was negative, was when x was greater than -4 and less than 2. Okay, so those intervals are our test intervals. So that is looking at how that x-axis is essentially divided into 3 sections when we have 2 x-intercepts. Then we have our 3 sections, and those are our test intervals. So let's take a look at part 2. We've got x squared minus 9x plus 14 less than 0, and so very first thing we want to do, we want to determine the roots. We want to figure out what our x-intercepts are, because that tells us what our intervals are. So we'll factor that, and we're looking at x minus 7 times x minus 2 equal to 0. So then that tells us that x minus 7 equals 0, which is x equals 7, or x minus 2 equals 0, so x equals 2. So our roots are x equals 2 and 7. So even if you wanted to get that visual on your graph, then you know that you've got one at 2 x-intercepts, one at 2 and one at 7. And so we've got our intervals of anything that is less than 2. We've got our interval between those 2 values, so when x is greater than 2 and less than 7. And we've also got that third interval when x is greater than 7. So now we want to pick values of x in the first interval and determine whether it's positive or negative, and go through the process for the other 2 intervals. So when x is less than 2, x could say be x equals to 1, and so then we're going to substitute that into x squared minus 9x plus 14. So we've got 1 squared minus 9 times 1 plus 14. So that's equal to 1 minus 9 plus 14, which is 6. And so that is going to be positive. Okay, and then picking a value between 2 and 7. So maybe I'll pick x is equal to 3. And substitute that in. 3 squared minus 9 times 3 plus 14, or 9 minus 27 plus 14 is equal to -4, which is of course negative. And x greater than 7, perhaps we pick x equals, I don't know, let's just go for 10. And so we've got 10 squared minus 9 times 10 plus 14, and 100 minus 90 is 10 plus 14 is 24, which, no surprise hopefully, is that that is going to be positive. So state the solution to the inequality. So when are we getting values? Which of these test intervals are we getting values that are less than 0, meaning negative, and that is in our central, our middle interval. So that solution is then x greater than 2 and less than 7. We could also graph the solution. Perhaps you might be asked to graph that solution, in which case I'll use my fancy number line here. And so we're looking at, here's 2 and 7, and they're open circles because it doesn't include those, and it's all of the values that are between. So that's how we can graphically show our solution as well. Okay, so use the table to state the solution to the following inequalities then. So now, when is our quadratic? Greater than 0, and so we're looking at those positive values. So that happens when x is less than 2 and x is greater than 7. Okay, or I should say or, because it can't happen, both can't happen at the same time. When is it going to be less than or equal to 0? Well, it doesn't really change from less than 0, other than the fact that we're going to add that or equal to on the bottom there. When is x squared minus 9x plus 14 greater than or equal to 0? And that happens when x is less than or equal to 2, or x is greater than or equal to 7. Okay, so the values, of course, and that you're substituting in, those are our test points, and we use that terminology, of course, when we were doing linear and quadratic inequalities in 2 variables, and we're picking test points in the solution regions to see if they worked out or not. Okay, so solving the inequality 8x minus x squared less than or equal to 0 using test intervals. So again, first thing that we want to do is factor that quadratic. That tells us what our x-intercepts are, what our roots are, and therefore tells us where our intervals are. So in this particular case, we can just factor out an x. So we have x times 8 minus x less than or equal to 0. So that tells us that we have either 0 or 8. Right, so x equals 8 or x equals 0. So I will just actually do that as a function just to make that a little bit more clear for you guys. So x equals 0 or x equals 8. So again, if you need that visual for yourself, then you know that you've got these 2 x-intercepts at 0 and 8. So here are our intervals. So we've got then x less than 0, x is greater than 0 but less than 8, and we've also got x is greater than 8. And we've got our sign, our function, which is 8x minus x squared. So picking a value that is less than 0. And certainly, I mean, you can include the or equal to as well, but that definitely has to be included in your final solution. Okay, so but please do not pick those boundary points, because it actually doesn't. If it tells you it equals 0, it's not telling you if it's less than or greater than. So don't pick a value that will end up equaling 0. So picking something that's less than 0, so let's say x is equal to -1. So then I've got 8 times -1 minus negative 1 squared, so negative 8 minus 1, which is negative 9, so that gives us something that is negative, and then something that's greater than 0 and less than 8, so let's say we pick x is equal to 2, so then 8 times 2 minus 2 squared, or 16 minus 4, which is 12, so that will give us a positive value, and x greater than 8, let's pick x equals 10, let's say. So we've got 8 times 10 minus 10 squared, so 80 minus 100 is negative 20, so no surprise that that is negative as well. And so when is that quadratic less than or equal to 0? So when is it negative? And that is negative when x is less than or equal to 0, or when x is greater than or equal to 0. And so again, if you wanted to come back and show your solution on a graph, then it is or equal to, so we've got our closed circles, and we're going to the left as well as to the right here. So that is our solution set. Okay, so using a sign chart, so similar idea as well, except you're not actually substituting in the values per se. Sometimes people are doing a little bit of substitution just to check themselves out, but for the most part it actually works out quite nicely, and it's really smooth, you'll see. And so this is the sign chart is actually kind of a nice little balance between sign analysis and case analysis as well. So let's take a look at Colin's work again. So x squared plus 2x minus 8 greater than 0, and also x squared plus 2x minus 8 less than 0. So first off, we factor, and so we know that we're looking at x plus 4 times x minus 2. So our zeros, or our roots, for the equation is negative 4 and 2. And so essentially what we have is, here is your x-axis, and when x is negative 4, what you have to think about is that when you substitute negative 4 into x plus 4, then that factor, so these are our factors right here. Okay, so the factors, when you substitute in negative 4, that first factor equals 0. When I substitute in negative 4 into x minus 2, that ends up being negative 6, but I don't need to write negative 6. I can just write the fact that it is negative. Any value that I'm substituting in that is less than negative 4 is going to be negative for x plus 4. Any value that I'm substituting that is greater than negative 4 is going to be positive then. So that covers the values that are between negative 4 and 2. Even if I substitute 2 in, 2 plus 4 is obviously 6, so that's positive. Any value greater than 2 substituted in is also going to be positive. So that's what you're seeing right here. Substitute negative 4 in, and that factor has a value of 0. Anything to the left or negative is on the left there, and everything to the right is going to be positive. Similarly, if I put in the other 0, or the other root, x-intercept, which is 2, when I put that into the second factor, that gives me 0. If I substitute in anything that is less than 2 into this factor, if I substitute in 1 minus 2, 0 minus 2, negative 5 minus 2, anything else, it's going to give me a negative. Put in a value greater than 2, and it's going to give me a positive. And now the product of your factors, so negative times negative is positive. 0 times a negative is 0. Positive times negative is negative. Positive times 0 is 0. Positive times positive is positive. And so at the end of the day, we are looking for this product of these factors greater than 0, meaning we're looking for the positive products, and that happens in the interval that is less than -4 or greater than 2. Okay, so it looks really complicated, but it's actually really, really slick as well. When you've got multiple factors, this is going to be so much more efficient when you're solving these complex inequalities then. Okay, so use the above chart then to state the solution. When is the inequality less than 0? So less than 0 is this -1, and that happens in this interval right here between -4 and 2. So that happens when x is greater than -4 and less than 2. Okay, so here's an example for us to try ourselves. So first thing, so they want us to solve the inequality -6x squared minus 39x plus 18 less than or equal to 0. So the first thing that you want to do is, of course, to factor so that we know what those factors actually are. So first thing, that's going to make life so much easier when it comes to factoring. I can see a common factor of -3, so we'll factor that out. That leaves us with 2x squared plus 13x plus 6. And then continue to factor that, and I've got 2x and x, and let's go with 6 and 1. And those should both be positive. So double check my factoring just to make sure that that all works out. Otherwise, we're going to end up in trouble. So you can see then, let's set up our sign chart then. So we have our factors. We have 3 factors in this case. We've got -3, we've got the factor 2x plus 1, and we've got the factor x plus 6. And then we want to leave room for the product. And the product is essentially, and I can write product, or if you guys want, you can write -6x squared minus 39x minus 18, which is, of course, the product of all of those above factors. And then you've got a couple of different ways to go through this. So you can do the chart like they did in before, or if you want, you can put in those zeros, which are -6. So I should probably write that out here. X is equal to -6. The other one would be if 2x plus 1 equals 0. So x would be then equal to -1/2. So we've got -6. And then we've got the interval between, and we've also got -1/2 and the interval above. So they have written it to the left of this and between these and greater than. It's up to you. If you want to use those arrows, you certainly can. The other option would be to write it out fully and to say, hey, what happens if x is less than -6? What happens if x is greater than -6 but less than -1/2? What happens if x is greater than -1/2? So easiest place to start is, of course, with your roots themselves. So if I substitute -6 in, -3 is obviously still going to be negative. If I put -6 into 2x plus 1, then that is going to be negative. If I put -6 into x plus 6, that's going to give me 0. Similarly, if I put -1/2 in, that doesn't change. The value of -3 is still negative. Enter in -1/2 here, that will give me a 0. Enter in a -1/2 here, that's going to be positive. And so if I take a look at -3, regardless of what the x value is, -3 is always going to be -3. It's always going to be a negative factor. If I take a look at the 2x plus 1, In this case, if I put in any value that's less than -6, it's still negative. Any value that is less than -1/2 but greater than -6, still negative. And you can see even right here, the fact that we've got 0 when we put in -1/2, so everything to the left of that is negative. Be careful though, because if it was written the other way around, say 1 minus 2x, then things can get a little bit trickier there when it's backwards to the right of the 0, or when I put in a value greater than -1/2, that's when that becomes positive then. So similarly here, if put in anything that's less than -6 into x minus 6, I end up with a negative value. It's the left of the 0. Put in anything greater than -6, and -5, -4, -3, anything like that, and everything is now going to end up being a positive value then. So now that we've got our sign chart figured out, negative times negative times negative will give us a negative product. Negative times 0 is obviously 0. Negative times positive is a positive. Negative times 0 times a positive, well, that's still 0. And negative times positive will give me a negative. And so we can see then that the inequality, so when is the quadratic, when is that product less than or equal to 0? So less than or equal to 0 is occurring right here. It's negative, here it's 0, and here it's 0, and there it's negative. So these are our intervals that will satisfy our inequality, and so it occurs when x is less than or equal to -6, or when x is greater than or equal to -1/2. Excellent, and that is that. So give it a go. For the last couple of enrichment questions, number 11, it will help immensely if you solve using a sign chart. It's going to be so much faster for you than trying to go through and multiply it all out and using test intervals. Okay? Have fun with it, and let me know if you have questions.